Today we're going to review how to plot points and the different aspects of the coordinate plane, such as the x, y axes, and quadrants. And then we're going to look at something new called relations. The first thing we're going to look at is the x-axis, which is right here in blue. So the x-axis runs left to right, and it's horizontal. So I've represented it here with the blue line. It's a horizontal line, runs left to right, and we always want to label it with an X. The next axis that we're going to look at is the y-axis in red, and this rises up and down, and it's a vertical line. Now, when those two lines, when the x-axis and the y-axis intersect, we get something called quadrants. And quadrants are four sections created by the x and y axes. So if we were to label them, we've got quadrant 1 here in the top right. We've got quadrant 2 here, quadrant 3, and quadrant 4. It goes counterclockwise. Now we know here that these are positive numbers on the x-axis, so 1, 2, 3, 4, 5. Positive numbers on the y-axis go upwards. Negative numbers on the x-axis go to the left, and negative numbers on the y-axis go down. And in the middle, we have the origin. That's where the lines meet. Now you'll notice in quadrant 1, the x-axis is all positive, the y-axis is all positive. So our points, any point there is positive. In the quadrant 2, our x-axis is negative, but the y values are positive. In quadrant 3, the x values are negative, and the y values are negative. And in quadrant 4, the x values are positive, and the y values are negative. So that's a little recap of the coordinate plane. So now we're going to look at plotting some points and just determining what quadrant they're in. The first thing we should do, though, is we should always number and label our graph. So we always start with the origin, and we label our x and y axis. Then we can go ahead and number the rest of it. So I like to start at the origin and fill in the x-axis first. So if I go to the right from the origin, this would be 2, 4, and 6. Then we'll fill in the negatives, -2, -4, -6. And I skip the lines in between the 2s, the 4s, and the 6s, just so I don't overcrowd the axis. I'm going to do the same thing with the y-axis. So I'm going to go upwards from the origin. I'm going to skip the line and put a 2, a 4, and a 6. Then I'm going to fill in the negatives, going downwards from the origin, skip the line, -2, -4, -6. So that's how I fill in the x and the y axis on my coordinate plane. Now let's plot the points. So we've got 4, 3. Both of those are positive. So I start at the origin. I go to the right over to 4 on the x-axis and then up to 3 on the y-axis, and I put my point there. And this is in quadrant 1. And I know that because the x and the y are both positive. In the next one, we've got -5, -4. My x is negative, my y is negative. That probably means quadrant 3, but let's have a look. So we start at the origin again. We go to the left to -5 on the x-axis, then down to -4. And that is in quadrant 3. For the third point, we're going to go to 1, -6. So this looks like it'll be a quadrant 4. So I start at the origin. I go over to the right to 1 on the x-axis, then down to -6. And that is quadrant 4. Finally, we've got -2, 4. So I go to the left from the origin to -2 and then up to 4. And that is in quadrant 2. And that's just how we graph on the coordinate plane. So let's talk about relations and what they are. So a relation is a set of ordered pairs which represent a relationship. So a relationship could be something as simple as someone is 14 years old and they weigh 100 pounds. The relationship is between their age and their weight. And we could represent that as an ordered pair as 14, 100. So this is an example of a relationship. We could also have relationships between time and snow totals. So for example, it may snow for 5 hours and we end up with 12 inches of snow. There's a relationship between the amount of time you work and the amount of money that is earned. So you may work 8 hours and earn $130. So those are examples of relationships. It's just showing how two things are related to. So there's several different ways relationships could be represented. And the first way is as a set of ordered pairs. So I have 4 points here, 4 ordered pairs, 1, 80, 2, 88, 3, 85, and 4, 70. And what makes them a set are these symbols here, those curly brackets. Anything in between those means that it's a set or a collection. So I've put some symbols up above each ordered pair. And obviously then these represent weather. So what this could represent is that my x value could be the time. So hour 1, the temperature is 80 degrees. So my y value represents the temperature. In the second hour, the temperature is 88 degrees. And we can continue on. In the third hour, we get some partly sunny weather, and the temperature has gone down to 85. And then the fourth hour, it's raining and it cooled off, and the temperature has decreased to 70 degrees. So collecting the data like that as a set of ordered pairs is one way to represent a relation. A mapping diagram is another way of organizing, kind of like a graphic organizer. So instead of showing as a set of ordered pairs, we have these little boxes that contain our x variables, or our x values, and our y values. So our x values would be our time. So 1 hour, 2 hours, 3 hours, 4 hours. And then we would put our temperatures over here. And I'm going to go in ascending order. So 70, 80, 85, 88. Okay, so there's our temperatures. So this is how we organize it. They go in order. And then to show the relationship between them, we would have to connect them from the X box to the Y box. So 1 hour was 80 degrees. 2 hours was 88 degrees. 3 hours was 85, and 4 hours was 70. So that's a mapping diagram. The values within each box are ordered from least to greatest, and then we just draw lines connecting the values that match up together. A third way of showing a relationship is with tables. So with tables, we just take our data and we input it into the table. So in this table, for example, we know that X represents our hours and Y represents our temperature. So at the first hour, it was 80 degrees. During the second hour, it was 88. During the third hour, it was 85. And then the fourth hour, it was 70. We often call these T-tables. The last way to represent a relationship is with a graph. So here I've got a graph where I've labeled the origin. I've labeled the x-axis in times, which is time in hours, and I'll label that X. And the y-axis represents the temperature, which is measured in Fahrenheit, and I'll label that axis as Y. Now I'm going to number each axis. So just for the sake of making it neat, I'm going to start with the x-axis, and I'm going to skip a line, put my first hour, skip a line, second hour, third hour, 4 hour. And then I'm going to do the same with the y-axis. So skip a line, 70, skip a line, 75, 80, 85, 90. So I like to make my graphs as neat as possible so the numbers aren't crowded. Now the way we would represent the relationship here is we just graph each point. So we know the first hour was 80 degrees. So I start at the origin, I go over to 1 on the x-axis, and then up to 80, rise up to 80, and put a point. That was hour number 1. Hour number 2, I start at the origin, go to the right over to 2 on the x-axis, and then up to 88. And this one I'm going to have to estimate. I'm going to say it's about right there. There we go. I had to zoom in a little bit. Hour number 3 was 85 degrees. So start at the origin, over to 3 on the x-axis, up to 85 and put a point. And then hour number 4, the temperature dropped. So I'm going to go over to 4 on the x-axis and up to 70. And that's the final point. So here we've represented the temperature as time went on, as time increased, in a graph. So we can use graphs, we can use tables, we can use mapping diagrams, and we can use ordered pairs to represent relations.